Hello everyone and welcome back to another math video. Today we're going to be talking about the Pythagorean Theorem, so similar to the problems that you see up on the screen here. Just a reminder, this is the normal version. If you'd like the speedrun version where we go through it pretty quickly, I'll link that in the description below. For your Ricasso Recap, you should already know how to solve square root equations, and you should know how to round decimals. If you want refreshers on either of these two topics, I'll link videos in the description below. Please go watch those before you start this lesson. All right, new lesson starts now. Here we go. So it says, what is the length of the missing leg? Okay, oops, that's too big. Missing leg. And leg here refers to this missing side of the right triangle. Now, Pythagorean theorem, named after famous Pythagoras, can only be used in right triangles. Okay, we know this is a right triangle because of the red mark. Now, Pythagorean theorem is a formula. It says a squared plus b squared equals c squared. C squared is a fancy word called the hypotenuse. Oops, hypotenuse. Hypotenuse. The hypotenuse is always directly opposite the right angle. So you find the right angle and you just go straight across. So in this case, 8 is the C. We know this is the B and this is A. So now let's plug in what we know. We know that A is 6 from our drawing, so this is 6 squared plus, we don't know what B is, we're trying to find it, let's leave it B, equals C in the drawing is 8 squared. Cool. So now we have an equation, so now we have 36 plus B squared equals 64, and now we just solve equations, right? Minus 36 on both sides. We're going to get b squared equals 28, and then again, we should know how to solve square root equations. Right over here, square root both sides, and the square root of 28 is a decimal. We get b, and let's see here, it says round to the nearest tenth. So if you type that in your calculator, you get 5.29, but rounded to the nearest tenth will be 5.3 final answer. This formula never changes. Never, ever, ever. All right, here's our cool clock for today, which means that it's time for you to practice what you just learned. Go ahead and pause the video and try these two problems on your own. And when you're ready, you can unpause the video and we'll check your answers. Okay, now that you've had time to work these problems, let's check your solutions. Okay, I moved these problems over to make a little bit of room here. Here is the work for the first problem. You should have gotten A equals 1.9. And for the second problem, here is the work. You should have gotten 4.1, but wait, pause. It says, what is the perimeter? So perimeter means we need to add up all of the outside. So when you add up all the outside, you get 17.9, because I need to add up all three, 7.5, 7.5, 6.3, and 4.1 gives me 17.9. All right, for this problem, you'll notice something is different here. Here, you're finding C, not finding A and B. So you are not sure which one is A, which one is B. The good news is A or B can be switched. This could be A, this could be B, or you could switch it. Doesn't matter, we'll give you the same answer. I'm going to call this A, this B. So now we plug in. And so here is the rest of the problem solved out. Okay, just square them, add them, and then square root at the end, you get C equals 85. All right, time to practice. Go ahead and pause the video, try these two on your own. When you're ready, unpause and we'll check your answer. Okay, now that you've had time to work these problems, let's check your solutions. Okay, for the first problem here is the work and final answer. It doesn't say to round. I think I accidentally cut that off. So if you were to round it to the tenths, you would get 7.5. And for the second problem here is the work. Hopefully we picked up on the fact that, again, it's asking you for perimeter. So once you get the C of 8.2, you need to add all three numbers to get your perimeter. All right, last type of problem is a word problem. So if you want to pause the video, go ahead and read this to yourself. All right, now that you've read this problem, You know that I love to draw wonderful pictures with any word problem, so here we go. So it says from her home, so let's draw a nice house here. Boom, this is Maddie's house. Maddie would have to walk due north to get to her, okay, so never eat shredded wheat. Here's your compass, that's how I remember it. Never eat, soggy wheat or waffles. Never eat soggy waffles is the best way to remember that. Never eat soggy waffles. Anyway, so Maddie has to go north to get to Emily's house. All right, so Emily's house is over here. So this is Emily. And then Maddie has to walk east from her house to get to Carter's house. So Carter's house is over here. Don't know why. Okay, we're just gonna go with it. There's Carter's house. And then they give us distances. So from Maddie to Carter, it is 6.5 kilometers. So from here to here is 6.5. And then from Emily to Carter's, it is 9.8. All right, so I see a triangle here. Although let's clean it up a little bit. Okay, here's our triangle. All right. We've got a base of 6.5. Here's our 9.8. Here's our right angle. And so now this is going to be C. We'll call this A. We're trying to find B because it says how far is Maddie's house from Emily's, and round to the nearest tenth. So now we're just going to do Pythagorean theorem. And so once you solve it all out, you get B equals 7.3. All right, time to practice. Go ahead and pause the video. Try these on your own. When you're ready, unpause and we'll check your answers. Okay, now that you've had time to work these problems, let's check your solutions. Okay, for the first problem here is the work. You should have gotten 4.4. Here's my wonderful drawing. Here's the window, the ladder, and I outlined the triangle that we're working with in red. And for the second problem, hopefully we realized, it says how far does Tyler walk? They want the perimeter. So your final answer should have been 13.8. Should have gotten C equals 5.8 and then added them all together. All right, that's it for today. I hope you all have a good morning, good afternoon, good evening, and good night.